For centuries, scientists have been studying this kind of black box, our solar system. We have had to rely heavily on models to explain the chemistry of these enormous bodies. One of these models concerned Io, the first moon of Jupiter.
How big it was and how much it weighed made it look just like the Earth's moon. So you started all of our modeling assumptions in the early days before Voyager started with the idea that Io was going to be basically like the moon. There was one problem. It was about 10 times brighter than the moon in terms of its surface reflectance.
Why was Io so bright? One model proposed that unlike our moon, Io had once been covered with great amounts of water.
Our model was of a dead lunar interior with a salty outside, probably blasted full of craters by meteorites. What Voyager found, of course, was fantastically exciting. And most exciting of all, we caught several active volcanic eruptions in the process of going on with Voyager 1, throwing plumes of debris up 100 to 300 kilometers above the surface.
What could be the source of the energy for these volcanoes? Investigators proposed the following model. Io hangs in space between Jupiter at one end and Europa at the other. They weren't volcanic eruptions like the ones here on Earth with lava exploding or flowing out of the ground.
So they proposed that the working fluid in this model was liquid sulfur or liquid sulfur dioxide, which can exist in the liquid state at fairly shallow depths below Io's crust. But when you build a model like this, you shouldn't get to thinking that the model represents reality. It will always change.